In this video, we're going to show you how to load a Quanta Geo DLIS file. Tap the Import button and select the DLIS file that you wish to load, and then you select the curves that you want to load. We're not going to load the flat images because we're actually just going to load the pads. And there is all the information that we'll load. The missing values in the curves are not minus 999.25, they're actually minus 9999. So we select all the curves and then we go into the set to value function in LogScope and we change the missing value to a maximum of minus 999 and a minimum of minus 999. And then we hit done and runs that, and it changes all the values to missing. The next thing we have to do is we have to interpolate those missing values, which we do. We perform this in two separate functions, one for linear and one for the angular functions, and then we're back to the plot. Next, we select the imaging function to select the Quanta Geo tool. In the Quanta Geo process data, the pads are the odd pads are the upper tool, and the even are the lower, so we select them in that order. Next, we'll just give the data a reasonable scale range of 0 to 93. You can use histograms, but in this case we're going to type them in manually. So we put the minimum and the maximum value in, and we're going to convert it to logarithmic. Bearing in mind that the Quanta Geo tool is a resistivity tool, the next step is to load the template, and I've created a special template from the BHI template called Quanta Geo. You can make as many templates as you like. So we load that in, and there we have the image, and it's displayed. We're then going to balance up the scaling of the various pads, and we do that by using first outlier removal. So we're going to remove all those extraneous values that gave us a funny data range. So we're putting in 0 and we'll put in 100, and then we hit the done button and it will go and process that. After we've done that, we can then use the destriping, and the destriping allows us to equalize the pads across each other. It's a very quick operation. We change it from individual pads to joint, and there we go. That's done, and it's improved the image. I'm just going to edit the gamma ray and add in the high resolution gamma ray so that we've got that in there. And then the next thing we're going to do is we're going to go down the plot and look at a section of interest. So in this, we've got the top, and then we put in a scale of 3,500 meters, and we're down there, and then we're going to go down the image a bit and find a section that we're interested in, and we're then going to produce an autocorrelation. So once we're there, we go back into the image function, and we choose auto dip here, and we are going to set it to 60 for the pattern size and 120 for the search size, and then we're going to change the maximum dip angle to 60 degrees, and then we're going to set the there to be some overlap, and then we're going to choose the start and the stop depth to just be this particular sand, because that's the interval that we want to look at the autocorrelation. So once we've done that, and we run the autocorrelation, it will produce the dips, and there are the dips, and you can see they're a fairly reasonable match to the formation. Thank you very much.